This video is going to show you how to build a work breakdown structure and PERT chart. We're using a very simple little example here of some sort of abstract sculpture built of a number of different concrete blocks. Now, that's the end result, but we had to get to that point. So we're going to use a crane, and the crane is going to put the blocks in order. The key thing is that because of gravity, we have to do the blocks in order from bottom to top. The first thing we're going to create is a list of tasks. So if you look at the left side of the screen, you'll see I have each of the different blocks listed here. The next thing we're going to fill out is the duration of each task. So in this case, we'll make it easy. We'll say each one just takes, say, 1 hour to put in place. The last step is we're going to start identifying the predecessors. In other words, what has to be done before each task can be completed. As you go through here, let's look at one in particular. In order to get block B placed, block A has to be put in position first. So that's why we have A listed as a predecessor of B. As you walk through the rest of your chart here, you'll see that most of these things have got a single predecessor except for H, which requires both C and F to be done. Once we have all of these done, we can start building out our next chart. The first two pieces are going to be A and E because those are on the ground. Once we have those in place, we can build the ones on top of them, which are going to be B, F, and G. After these three are finished, we can go on to C, but we can't do H yet because H requires C to be done. Once C is finished, then we can do H, and then we can do D as well. So this is a way of looking graphically at the table that's on the left. Once we build this out, we can identify a couple of key things. One of the most critical things is what's called the critical path. The critical path is saying what things have to be done on schedule in order for the project not to slip beyond its end date. If anything along the A, B, C, D, or H moves late, then the overall project will take more than 4 hours. E, F, and G, however, can move later and still be okay. As an example, you can see that on this one, if they get delayed by 1 hour, it's still the overall project is able to be finished up. Now let's look at a modification. I went ahead and changed a couple of things here. F now takes a duration of 2 hours, and G is going to now be put on top of F. Now you see that as I modified the structure on the left here, the critical path is also changing. Now there's no slack in our schedule. That means if anything is delayed by even 1 hour, the overall project is going to be late. Now let's think about how to deal with limited resources. Let's say I only have 2 trucks or 2 cranes to be able to work on the project. Because I only have 2 cranes, you can see that the final step is requiring too many resources. What we're going to do then is we will delay H in the light of having limited resources, which then gives us a new critical path. Furthermore, because I could delay G or F or E now, I now have a new slack in my project of 1. So overall, the key concepts here are first to create the work breakdown structure. Listing out your tasks, find the duration of each, and then find the predecessors. After you create your work breakdown structure, you can start to level it out by scheduling. First, you're going to do the work breakdown structure that's unconstrained by resources. That way, as you deal with actual resource limitations that might change in your project, you can always revise and adjust. But if you deal with the work breakdown structure limited resources first, you lose the information that allows you to adjust and reschedule the project later on. The last critical concepts are critical path and slack. Critical path are the steps that cannot be delayed at all if your project is going to finish on time. Slack is sort of like the reverse. Slack says this project can be delayed and the project will still come out on time.